Okay, so you have some examples for conditional probability and two-way tables, which the blue classes will get a taste of before we take PSAT. And it will be on our next big interim exam, which is our next test. So we've got some examples with spinners. We've done examples like this year, I'm pretty sure. What's new here is you're going to be asked about the probability of an event given a condition. So, for example, this is a good one. The soda company conducted a taste test, and then here are the results. What's the probability that a participant chose soda C or was under 20? So probability that someone chose soda C is the sum of all of these values, okay, or was under 20 would be the sum of all of these, but these 126 people chose soda C and they were under 20, so we wouldn't count them twice. So if you add up these, it comes to 228. That's where this 228 is coming from. And then if you add these up, that gives you 200, 330, and 44, and 126. And then you're not going to count these 126 people twice. So that's why they're subtracting it. So this notation is just saying probability of C or under 20. So there's the probability of choosing C. There's the probability of being under 20 minus the probability of people who chose C and were under 20. Okay, here's the probability as a fraction, as a decimal, and as a percent. What is the probability that soda A was chosen? Well, then I would just add up everyone who chose A. And I would divide that by the total number of people. Let me see, why is this? Is that 800 total? Okay, so it is 800 total. It surveyed 200 people in each age group. Okay, that's what was throwing me off. So that probability for soda A, that's just basic ability right there, 326 out of 800. And then part C would be conditional probability. If soda A was chosen, what's the probability? So if I'm looking at soda A, if I'm looking at these people, what's the probability that the participant was 60 years old or older? So then you would say 141 out of the people who chose soda A, which is 326. So that's this probability down here. So let's do some of these, and it will be worth it if you do these because we will be using some of these same problems in class on the second class of the week. So number one, 2 six-sided dice are thrown. This is your typical problem. How many ways are there to get 7 points? So I think we can quickly sketch this out. Okay, so you have 1 six-sided dice. So die number 1 and die number 2. Dice is plural for die. Okay, so I'm creating a 6x6 table. So how many ways are there to get 7 points? I could just look at those possibilities and not look at all the possibilities. 1 plus 6 is 7, 2 plus 5 is 7, and so on. 3 and 4, 4 and 3, 5 and 2, 6 and 1. So there's 1, 2, 3, 4, 5, 6 ways to get 7 points. So for part A, that would be 6 out of 36. Oh, I think I just answered both of those. So there are 6 ways. For part A, there are 6 ways, and the probability is 6 out of 36, or 1 over 6. Okay, if you got 7 points, what's the probability that the result on one of the dice was a 5? So if you get 7, the probability that one of the die has a 5 is this one right here and this one right here. So that would be 2 out of the total, which would be 36, 2 out of 36, out of the 6 out of 36. So this is the probability of getting 7 points, and they're asking what's the probability that the result on one of those is 5 if you got 7. So it's 2 out of 36 divided by 6 out of 36. So that would turn into 2 over 36 times 36 over 2, which would be, 36 over 6, which would be 2 over 6, which would reduce to 1 over 1 over 3. Okay, number 2, Elizabeth and Scott are playing a game at the state fair that uses 2 spinners that are shown in the diagrams at right. The player spins both wheels, and if the colors match, the player wins the prize. So we've seen this before, but maybe not with these proportions. Make a diagram. So I'm going to do an area model. I guess you could do a tree. It's up to you. Now the dimensions don't have to be in proportion. I kind of like to do it that way, but you don't necessarily have to. Okay, so for spinner number 1, I'm noticing that red is 2/3 and blue is 1/3. So that's why I made this column look like it's 1/3. Blue, 1/3, red, 2/3. Okay, and then we have spinner number 2. And each color has a equal chance, so that's 25% chance for each one. So let's divide this up 4 ways. Oops, that didn't come out perfect, but that's okay. So red, green, let's do red, yeah, red, green, blue, yellow. And each of these is a 4th. What's the probability of winning a prize? Well, you win a prize if the colors match. So red and red, the probability of getting red on the first spinner and red on the second spinner would be the area of this rectangle, which would be the base times the height. So 1/4 times 2/3 would be 2/12, which would reduce to 1/6. When we write the 2 over 12 equals 1 over 6. Okay, probability of getting blue and blue is 1/4. The height is 1/4. The base, the length is 1/3. So 1/4 times 1/3 is 1/12. So the probability of winning a prize for part B is 1/6 plus 1/12, which I need a common denominator if I'm adding those. So 1/6 with a denominator of 12 would be 2. 6 times 2 is 12, 1 times 2 is 2. So 2 over 12 plus 1 over 12 would be 3 over 12, which would reduce to 1/4. If you won, what's the probability that the matching colors were red? So they're saying only look at the condition of winning. So for part C, you're looking at the probability of red if you are a winner. So I'm only looking at these two probabilities, and I'm going to say, well, the probability of getting red is 1/6, so it's 1/6 out of, divided by 1/6 out of the total of these, which was 1/4. So 1/6 divided by 1/4 would be 1/6 times 4 over 1, which would reduce to 2/3. Okay. An airline wants to determine if passengers not checking luggage is related to people being on business trips. Data for 1,000 random passengers at an airport was collected and summarized in the table below. Okay, so we've got people traveling for business, not traveling for business, check baggage, not check baggage. What's the probability that a passenger did not check baggage? Well, that means I need the total, and they said that the total was 1,000. Data for 1,000 random passengers is summarized below. So the probability that a passenger did not check baggage, no baggage checked, are these two totals. So let's do 387 plus 294, so 681, which would be, you know, the little trick, right? Just move the decimal point 3 places to the left when you're dividing by a multiple of 10. So that would be 0.681. If a passenger is traveling for business, what's the probability that the passenger, so if the person, I need another highlighter. Let me get something else. Okay, if a passenger is traveling for business, so this group, so these 103, these 387, what's the probability? Let's see, what's that total? $490. So this total is $490. So out of the 490 people traveling for business, what's the probability that the passenger did not check baggage? So that would be 387. So 387 out of 490, and I got 490 by adding together 103 and 387. So that's about 79%. Okay. In Canada, 92% of the households have televisions. 72% have televisions and internet. So 92% television, 72% TV and internet. What's the probability that a house has internet given that it has television? So if I'm looking at the people who have television, which is 92%, out of those 92%, what's the probability that they have internet? Well, that's the people who have the television and internet. So then I would do television and internet group divided by the people who have television. So this is TV and internet divided by TV. So I'm going to do 72 divided by 92, and I got 0.78. So 78%. Okay, there is a 25% chance that Claire will have to work tonight and cannot study for the big math test. If Claire studies, then she has an 80% chance of earning a good grade. If she does not study, she only has a 30% chance of earning a good grade. So let's make an area model for part A. What problem is this? This is number 5. Okay, so 25% chance she's going to have to work and cannot study. So let's start with that. Now these don't have to be in proportion, but I kind of like to do that. 25% would be 1/4. That's not exactly 1/4, but close enough. So if she works, then she does not study. And that probability is 25%. Okay, if she does not work, then she's going to study for a 75% probability. Okay. If she studies, so if she doesn't work and she studies, then she's got an 80% chance of getting a good grade. Okay, so let's just look at this side where she's studying. I'm going to make this look like it's 80%, so right about here, there's an 80% chance that she'll get a good grade. If she studies, that means there's a 20% chance that she will get a bad grade. Okay, and then if she does not study, she only has 30% chance of getting a good grade. Okay, so let's look at this side and make this, and actually get rid of this. Okay, that's just for if she studies. If she does not study, she has a 30% chance of getting a good grade. So I'm going to make this look like 30%, which means there's a 70% chance that she will get a bad grade. Okay, so now we could multiply all these probabilities, but I have a feeling we don't need to. Calculate the probability of Claire earning a good grade on the math test. So the probability of her earning a good grade would be 30% times 25%. So 0.3 times 0.25. 0.075 shows that's her chance if she does not study, if she goes to work. And then 75% times 80%, so 0.75 times 0.8 is 0.6. So then the probability of her getting a good grade would be 0.075 plus 0.60, which is 0.675, which is 67.5%. Okay, if she earned a good grade, what's the probability that she studied? So I'm only going to look at that condition. If she gets a good grade, what's the probability that she studied? Well, the probability of her getting a good grade, we just figured out. Or what's the probability of her, sorry, I gotta read this again. she got a good grade, what's the probability that she studied? Okay, so the probability of her getting a good grade is 67.5%. So the probability that she studied is 60%. So then the probability of her that she studied given that she got a good grade, given a grade, is this probability right here, 60% out of the total for getting a good grade. So 0.60 divided by 0.675 would be so about 89%. So some of these get a little bit, you just might have to, like I'm doing, read it a couple of times and say, wait, am I looking for the right thing? And that's something we're going to be discussing in class, next class. Okay, number 6. A bag contains 4 marbles, 4 blue marbles, 2 yellow marbles. 2 marbles are randomly chosen. The first marble is not replaced before drawing the second one. What's the probability that both marbles are blue? So we have 4 blue, 2 yellow. So let's draw this out. That's 6 marbles total. 4 are blue, 2 are yellow. Okay, so you draw a marble and then it's asking for the probability that both are blue. So if the first one I pick is blue, I'm going to be left with 3 blues and 2 yellows. So the probability of the first marble being blue is, that probability is 4 out of 6. 4 out of the 6 marbles are blue. And then the probability of choosing the second marble as blue would be 3 out of 5, because now I'm down to 5 marbles. So the probability of both blue is 4 over 6, this length and this width, times 3 over 5. So 12 over 30, which will reduce to 2 over 15. Part B, what's the probability that both are yellow? Okay, so first I start with all of the marbles. So the probability of, I guess I really don't need, yeah, I do need to draw a new picture. Probability of drawing the first one, yellow, would be 2 out of 6. And then that yellow is gone, so now I'm down to 4 blue and 1 yellow. And the probability of choosing a yellow there would be 1 out of 5. So now the probability that both are yellow So then the probability of getting both yellow would be this rectangle right here, which would be 2/6 times 1/5. So that's 2 over 30, which reduces to 1 over 15. Okay, what is the probability of 1 blue and 1 yellow? Well, you can kind of see the pattern here. I'll draw it out if that's helpful. So the probability of choosing 1 blue Okay, well, the probability of choosing one of these as blue would be 4 out of 6. And then if one of those blues is gone, then I'm down to 2 yellow, 3 blue. So 1 blue, 1 yellow would be this box right here. So 4 over 6 times 2 over 5. So probability of 1 blue, then 1 yellow would be this rectangle right here. So that'd be 4 over 6 times 2 over 5, which would be 8 over 30, which would reduce to 4 over 15. Okay, and then part D, if you're told that both selected marbles are the same color, what's the probability that both are blue? Okay, so if you're told that both are the same color, so the probability of getting both the same color for blue was 2 out of this should be a 5. I put 15, that's 2 out of 5. Okay, so the probability of choosing, if you're told that both are the same color, what's the probability that both are blue? Well, the probability that both are blue is 2 out of 5. Sorry about that, that should be a 5. And out of both being the same, given that they're both the same color, that was 2 out of 5 and 1 out of 15. So probability of both blue given both same color. Okay, so both blue is 2 out of 5 out of the probability that they're the same color, so that would be this probability and this probability added together. This was both yellow, this was both blue. Both blue is 2 out of 5 out of 2 out of 5 plus 1 over 15. And that works out to be 2 out of 5 divided by, I need a common denominator here, so 2 out of 5 is the same as 5 times 3 is 15, 2 times 3 is 6, plus 1 over 15, so that's going to be 7 over 15, which is going to give me 2 over 5 times 15 over 7. Dividing both of these by 5, that would give me 6 over 7. Okay, then we have Cal's computer warehouse. Okay. He wants to know the probability that a customer who comes into his store will buy a computer or printer. He collected the following data during the recent week. 233 customers entered the store. 126 purchased computers, 44 purchased printers, and 93 made no purchase. Draw a Venn diagram to represent the situation. Okay, so let's do printer, computer. 44 purchased a printer and 126 purchased a computer. Okay, and then 93 didn't make a purchase out of 233. So let's see how many made a purchase. 233 minus 93 is 140. So 140 people bought something. And some of those people bought both, because if I add 126 plus 44, I get 170, but only 140 people purchased something. So this is 170 total, which means some of these people, there's some overlap here. So I'm going to do the people who bought the, well, what's the difference between 170 and 140? That's 30. So there's 30 people who bought both. So the overlap is 30. And then I'm just going to do 126 minus 30, which would be 96. And then 44 minus 30 would be 14. And there's my Venn diagram. Okay, based on this data, what is the probability that the next customer who comes into the store will buy a computer or a printer? Okay, well, 140 people bought a computer or a printer. So for probability of computer or printer, that would be 140 out of 233, because it said, what's the probability that the next customer who comes into the store? And 233 people came into the store. Okay. Cal has promised a raise for his salespeople if they can increase the probability that the customers who buy computers also buy printers. For the given data, what is the probability that if a customer bought a computer, he or she also bought a printer? Okay, so probability that you buy a printer given that you already bought a computer. Well, 30 people bought both, so that's got to be 30 out of the people who bought the computer, so out of 126. Okay, I'm going to try and get through. I might just skip the last one to save us some time, and we'll just make 8 the last one. Okay, a survey of 200 recent high school graduates found that 170 had driver's licenses and 108 had jobs. 21 said they had neither a driver's license or a job. So we're going to make a two-way table. I'm not really explaining some of these very much. I'm trying to squeeze all this into a video, and also I kind of want you to talk. This is going to be related to our class, and I want you to talk about it with your group when you're in your group. Okay, so we are dealing with 200 high school graduates, people who have driver's licenses, and people who have jobs. So let's do driver's licenses and jobs. Okay, we'll do a yes and no for driver's license and a yes and no for job. And I know there's 200 total, right? Survey of 200. Yeah, so 200 is the total, and 170 had a driver's license, so my total for driver's license is 170. 108 had jobs, so let's go jobs, yes, 108. 21 had neither. 21 had neither, so 21 right here. So then you just fill in the missing pieces. 200 minus 108 would be 92. 200 minus 170 would be 30. And this is the kind of thing that would be a good discussion with your group. How did you get the number 92 or the number 30? Those are things I want you to discuss in your group. And then you just find your missing pieces. So let's see, if I'm looking at no for driver's license, that's going to be 9. If I'm looking at no for, what is this, jobs, that's going to be the total minus the amount that don't have a job. So that's going to be 71. And then 9 from 108, so 99. Okay. If one of these 200 graduates is randomly selected, what's the probability that he or she has a job and no license? So job and no license. Now they said if one of the 200 is selected, so that's going to be probability of job and no license. 9 out of 200. Okay, and then if the randomly selected graduate is known to have a job, so that means you're only looking at people who have jobs. What's the probability that he or she has a license? So if I look at jobs, yes for jobs, that's 108 people. So probability that he or she has a license. So probability of having a license given that they have a job. So then I'm only looking at this row right here. So out of those 108 people who have a job, 99 people have their license. Okay, we'll stop there.